Hello there, today we are going to discuss about the modeling and pushover analysis of eccentrical braced frame in SAP 2000 software. So I am going to here create a new model. Then I will choose initialize model from default setting for force, distance and temperature here. Then default material, one of the standard here. Then the select template will be 2D frame. I will choose here the 2D frame type as a braced eccentric, and the number of stories will be 4, and the number of bays is 3, and the gap distance between here these frames is 1.2 meter. I will choose here the section properties, but I will define it. I'm going here to plus sign, then I will do not add new properties, I will import from properties. Then I will select here the frame section property type as a still, then I flange here. I will select one of the code. Then you can choose from here as well. It will be W200. The last one here, it is W200, but the last one will be like here, so it will be W200 by 35.9. Then I will select OK, then OK again. So it is for column. I will just modify and will do here column. Then you can just remove this one and no problem, this is column. Then you can choose material also from here, it is still. Then I will just press OK. Then again I will import for beam, so this time I will import it for beams. I will import and will select still and I flange. This time I will choose W150 by 37. Press OK and OK again. Here I will modify this ones and I will modify the beam name here, it is a beam. This OK. Again I will do import for braces, it is still, but this time it is not I flange, it is tube. Then I will choose here HSS, it is 101, it is HSS 101 by 101 by 9.5, the last one. So I will press OK. Then I will press OK again. I will modify it, it is brace. Then I will press OK again. Then again. So this is for beams and column and brace. Then after that I will press OK. So it is our frame. I do not need this window. I will select all these nodes and will assign the supports, joint, restraints. I will make it fixed supports. If you wanna just do hinge support or pin support, it's up to you. Support and will apply OK here. All the supports are fixed. Then I will do here. So if you want to create another braces, it is easy. You just select these ones and select here the braces. Then you will define the braces as well. If you want to just create another brace for beams, columns and others, you can just do here very simple from here. So now I will define here hinge properties. Here I am coming to hinge. Then I will add new property and use default for steel. Then I will leave it is a column hinge. I will make it column. Then so like column is a members which can bear shear forces moment. Then I will select here, it is interacting PM2 M3. Then after that you can select here the hinge properties like hinge specification, like moment curvature or moment rotation. Or you can just choose here the skill factors for rotations, if you can calculate and write it here, or calculated by a system or taken from a code here. And you can just do some other condition for moment rotation or moment curvature and others here. Or you can just do some modify moment rotation curve information here. You can do the immediate occupancy, life safety and collapse prevention information. You can just adjust and change whatever you have calculated, or you can just change here this curve like moment yield or rotations, or like the life safety and other information. You can just change from here as well. Then you can just like edit and put different value. Okay, then I will do not change as it is OK. And you can modify here the interaction surface, like choose here the different codes and other information for elastic or plastic elasticity. Then I will press OK. I will remain it as it is, as a default. Then I will do not change. After that I will just press OK. So I have defined a hinge for column. If you want to just change something after that, you can just edit it and go there and make a change. Now the same, I will add a new property for beams, like hinge for beams. I will make it still here and will name it as a beam hinge, and the hinge type will be deformation controlled, and you can do the force control or deformation control. And this time I will select here it is momentum 3. Then here it is the displacement control parameters, like the curve, like it is the symmetry curve, and you can just change some values here as well. And you can select type is moment curvature for moment rotation, and here the hysteresis type will be, like I will choose here this time degradings, or you can just select another one, so it doesn't matter, and you can just change other values which you have calculated. But if I select degrading, and the programs will automatically calculate it, and you can just modify here the other parameter as well here, and you can just change some information for tension or compression here as well. And you can select here the different positive or negative information about immediate occupancy, life safety, or collapse prevention. So but I will do not change. It is okay, it is correct, but I will change here the hysteresis type here. Then I will select press OK, then OK again. So I have defined hinge for beams in column, and for the brace hinge we will use automatic hinge. So I will press OK. Now I will select all the beams here. I will select one by one, or you can just select all the beams there as well. It is also very easy. I have selected all the beams, or you can just do here select all the properties here. You can do from here as well. Then I'm coming here to assign here frame and hinge. So I will select here hinge for beam, and it is relative to clear length. I will select this ones, and it is 1.1 from one end. Then I will add. Then I will select here the different from another side. It will be 0.9. I will add. Then I will press apply. So look here, the hinge for beams and both ends. Then I will press OK. So here the hinges appeared in beams. Now I'm going to select all the columns here. The properties I'm going to select here, properties, and the frame section. I will select all the columns, select. Then I'm going to assign here frame and hinge here. I will select here column, and the relative to clear length is 0.1 for one end, and add. And also for another end it is 0.9, add hinge. Then I will apply OK. Look here, hinge for column also has been appeared. This is hinge for beam, and another vertical is hinge for column. Look here, hinge for beams in columns has been shown here. Okay, now I will select all the braces here. I will select all the braces one by one. So then after that I will assign hinge, assign frame, and here hinge, and this time is what auto hinge we will apply. So like it is the middle brace, it is the mid section. Then I will add. I will select here the code, like here you can just choose different code, but this is the earliest one. Then here, like which one, like I will use steel brace. Look here, it is steel beam, steel columns, here column others like concrete, and here is for beams concrete or concrete beams, and here is steel brace. Then I will select this one because it is for braces. Then I will select OK, then apply and OK again. Look here the braces, look here the hinge for brace has been visible here for braces as well. So we have hinge for beams, hinge for columns, and hinge for braces. All the hinges has been assigned. Okay, now I will select the whole structure here, and will assign here. Then I'm coming here to assign frame and hinge overrides. Here I will select here point, the stiffness ratio is 0.1, then apply and OK. So now I am going to define here the load pattern. Here it is a dead load and another one will be super dead load. Then I will select here like super dead load, I will select here, then I will add. Then we have live load, and here I will select here live and press OK, then OK again. Now I will select here all the beams. Here it is properties, frame section, and select all the beams, and assign here the load, frame load, and here distributed. So it is a super dead load, and here so uniform load is 10 kilonewtons, and it is load direction is gravity. Then apply OK. Then I'm going here to get previous selection and will go to assign here frame load, and here distributed, and this time the live load, and it is uniform load and 15 and gravity, and after that apply OK. We can just confirm load, like we have the load patterns, and it is super dead load, and we have the live load. Okay, so sometimes the load in roof is given differently, so you can just assign different load for this roof. So now we are going to here define the load cases. Here we do not consider a model, but we will just change some super dead load to nonlinear. Here I will modify and I will select here to the nonlinear, and then press OK. Then live load as well, modify here and nonlinear, and I will continue from state it is like super dead load. Then I will press OK. Now I will define here the pushover as well. I will define here the pushover and I will name it pushover. Then here it is a load case is static and it is nonlinear. Pushover is nonlinear static analysis, and here I will select here the geometric nonlinearity parameter will be P delta effect will be considered, and here I will choose here accelerations and UX, and here the scale factor is -1, like it will be considered to this direction, so that is why I have changed. Then now we will do some modification here, other parameters modifications, and modify these ones, like it will be displacement control, and use the load like 1 meter to push like the structures above here, push in 1 meter, and the degree of freedom will be U1. Here are joint 5, like it is joint 5 is there above. Then I'll press OK. Here look here, the joint 5 it is showing here, and every node has a number, and here the result saved. Here I will select here the multiple state, then I will press OK, and also the nonlinear parameter is also important, and I will modify these ones, and you can select here the interactive only or interactive event to event. Okay, I will make it as it is, and maximum total step is 200, and maximum null steps for static is 50. I will do not change all these values, it is okay, and it's a default is correct, but you are able to change if you want, or you have calculated before, you can just change here and adjust. Then I will press OK, and will press OK, and I have defined here the pushover. I have defined the pushover both nonlinear static analysis and modified the super dead load and live load as well, and we do not consider model, and we'll press OK again. Now everything is completed, and now we are going to just save this model and we'll run analysis. I will first save it. Now I have saved this model. Now I'm going here to analysis. So analysis is going on. Look here, pushover analysis. It will take some time because it is pushover analysis. So analysis has been completed. There is no error, and then I will press it done. After analysis, I am coming here to deformed shape. Here I will select here the pushover and will select maximum here. Here I will draw and will apply. Okay, so look here, some hinge has been shown here. Like here, this gray color, it is like hinge position, but there is no hinge exist, means there is no hinge generated. But here in these colors, like it is a collapse prevention, but we have just one hinge which is in red, but it is not a big problem, and other is okay. So look here, and you can just do start animation or go for another step as well to look here whether other hinge has been generated there or no, because we have few hinges here. It is like all are in the collapse prevention state, only one hinge is in red color, and even this hinge is also in brace, not in beams in column, this red color one. And we can just go for another step as well. You will come here again to the deformations and you can select a different step, like it is step 1, and will apply. Okay, so in these steps only one hinge has been created. Then I will go to another step. Look here, this hinge is also in this brace, only one hinge we have. In other portions of beams and columns, like there is only hinges showing, but hinge is not created or generated. Then look to third step, like there is 2 hinges, and fourth step, like there is 3 hinges. And look here to another step, like we have few more hinges. Okay, and look to another one, we have another hinge here also. And look here, only in this stage we have one hinge which is in red color, but that is also in brace, not in column or beam. And look to another step, here the same, it is also the same step 9. Look here, the step 9 we have a few hinges, and only here step 10 we have few hinges, and we have overall only one hinge which is in step 9, and step 10 which is in red, that is also in brace. And you can just go to another step as well. So it is 0 step and 1 step, 2 step, like there is hinge from life safety to collapse prevention. And here we have another hinge as well, here in others. Look here. Now I am going here to display here and show static pushover curve. Look here, it is a pushover curve. So this side is in displacement and that side is base shear capacity, displacement and base shear, and it is pushover curve. Look here, and pushover curve. You are also able to export this pushover curve to Excel sheet, or you can just draw there. And look here, and you can just export to PDF for Excel sheet, or you can just do all this or print it. And look here, if you want to just display table, it is displacement and base shear, and you can just draw an Excel sheet. Or we have another points as well here, like it is LS or IO or CP, which is limit state or immediate occupancy or collapse prevention. All these points here exist, and you can just draw in other sheets or in another programs. Okay, everything here exists. Look here, CP and immediate occupancy on life safety as well, and you can just export here to Excel sheet or to Excel sheet. So it will automatically export to Excel sheet, and you can just draw there pushover curve and other LS and IO or CP points, which is limit state, immediate occupancy or life safety, collapse prevention. You can just press done, it is pushover. And if you want to just, or you can just draw here for this too as well, press OK. Look here, we have exported this to Excel sheet as well. We have displacement and base shear and another points for CP, LS and IO. And here you can just get another information for yield displacement and yield strength, and you can just compare with other codes, like we have American Technological Council 40 and we have FEMA and another American Standard code. So in other codes you can just compare and get some good information. So like I will select here the FEMA, and you can look here other information here, like the performance point VD and also other SA or SD. You can just get these values as well, and performance point and the performance point for period and ductility as well here, and other points as well. You can get all the information from here, and you can also select here this one's American ATC, and look here other information exists here, like we have VD and SA and SD values here, and other performance points are here. You can just export also to the Excel sheet or to other sheets you can draw there as well. And also this is the pushover curve, and it was all information about this curve, and you can get different values from other codes as well. And the best thing is that you can just export each and every information to other Excel sheet or other sheets, and you can just further interpret for good understanding. In the last things, I will show you the hinge results, display and show hinge results here. Like here the different hinge select, I will select, like you can select column hinge or beam hinge. I will select beam hinge. Look here, like I can just select here pushover and do different step. Okay, look here this hinge position and hinge locations, and you can just select other step as well. It is for beams, and you can select different beam hinge and go for different step. Like here is for beam, another step. Look here, it's position, but hinge is not created in this portions, and you can just go different. Look here, it is for beams, and you can just select for column as well. Look here and do for different steps, and you will see all the information about degree of freedom and moment and plastic and other information. All the parameters will be showing here. It will be also indicated hinges in which state, like different colors. You can select another hinge and different step. Okay, and other parameters you can just show here. I will select here for braces as well, because that is automatic, and like it is for brace, and I will go different step. Look here, it is showing there, and I will select another brace. It is like automatic, different steps. Look here, like one hinge, like in hinge state, it is showing here hinge state, and hinge status, it is also showing here. You can just understand good information from here, from this parameter, and different step. Like we do not have hinges here, but in this stage we have hinge and hinge state and hinge status, it is showing here. Also, like you can plot control parameters like backbone hinge here, and also scale factors. Look here, it is backbone curve. You can look all the information from here. Like you can go for different stage. Like I will select here another brace here, and different. Look here, this hinge position is changing, and it is state in backbone curve. It is showing there backbone curve and left and right both. You can just select top and bottom border. You can also select and change the step here. Look here, it is changing, and you can do for another brace as well, or you can do for column as well. Like I will come here to the column and will select different step, and look here, you can select, like when there is hinge, the backbone curve will also be showing here. I will go back to the brace here. Look here, it is a brace, and the backbone curve is also showing in different steps. Okay, you can get many information from here and control the deformation in other parameters when you want. It was modeling and pushover analysis of brace frame structure. I have explained everything, and still if you have any doubt and problem, you can write it down in the comment box, and do not forget to subscribe our channel and recommend it also to your friends, to other engineers, and stay tuned for another informative information. and press the bell icon for getting the video notification. Then bye bye, see you soon.